180, correct? How about from here to this mark? 90 degrees, everybody with me? Right? So 360, if you divided it into half, it's 180. If you divide 180 into half and stop here, 90 degrees. Therefore, this marker right here would be how much? 45. And then what would this angle be right here? 30 degrees, because that's 1, 2, 3 sections, correct? So I want us to start with 30 degrees. I want us to count every section that's this long. So that will be one section, one section, one section, counting by 30. So if you follow along with me, right, 30 degrees, we add another 30 degrees, and we're going to circle all the way around. And I should have started here with 0, actually. Okay? So you are going to go all the way around until you do one full revolution, which you guys told me was 360. So go all the way until you get to 360. So keep going, and then I'll follow behind you. Keep adding by 30s. Yeah, you can get one from the box. All right. 15. So that would be the first thing you do when you guys are doing the unit circle. It's just add by 30s all the way around. Okay. Now you're going to notice that you got almost every single line. Okay. You only had 1, 2, 3, and 4 segments you didn't label. Okay. And you guys originally told me that this angle right here was which one? The 45. Very good. So I'm going to put 45 right here, because that's halfway between 0 and 90, right? 0 to 45, 45 to 90. Now, notice that between 30 and 45 there is 15 degrees. So you're going to use that pattern to help you fulfill all the others. So from here to here is 15 degrees. We know from here to here has to be 15 degrees as well. So what would this angle measure be if that's the case? 135. Very good. So I want you to go ahead and do the other two. If you know that 120 plus 15 is 135, find the other two angle measures that are missing over here. The unit circle is symmetrical, so finding those angles will make it that easier. All right, so at this point, you should have written 225 and 315. Everybody get up to here? No problems? Okay, so again, making notes for yourself as you guys are proceeding further. The first step was count out your 30-degree angles. The second step was find the missing 4 angles by adding the 15-degree increment. Okay, so this first step right here, which will take you maybe minute and a half to do, is the first step to earning a 33% on your unit circle quiz. You've done a third of what needs to be done. Okay, so hopefully at this point you're like, oh, this is not too bad. Okay, now if we do angles in degrees, because we do the degree angles first, now we have to also provide the angles in radian measure. Okay, so we're going to do next is populate those same angles we just did, but we're going to do radians, and I'm going to show you how to count out the radians. Okay, so here we go. So step 3, Next, do the radians. Now, we had done the 30-degree angles first, so let's do the radian angles that are equivalent to 30 degrees. So let us convert 30 degrees into radians like we've done in the past. What did we multiply 30 degrees by to get radians? Pi over 180, that's correct. Okay. So when you multiply 30 degrees times pi over 180, we multiply the numerators, 30 times pi, to get 30 pi, and then the invisible 1 under the 30, 1 times 180 is 180. And then you reduce the 30 over 180 and you will get 1/6, or pi over 6. Remember in your calculator, if you don't remember how to reduce it, just type 30 over 180 using that alpha y equals button, and when you hit enter you'll get 1/6. Okay? But notice that the zeros cancel, and 3 over 18 are both divisible by 3. 3 divided by 3 is 1, 18 divided by 3 is 6. Okay, so let's come over here, and by the 30-degree angle we're going to write pi over 6. Okay. And we'll put the 0 radians here since we're starting with 0. Okay. So here's what I want you guys to notice. We're still going to count in these increments, but instead of counting by 30s, we're going to count by pi over 6. Now, if that's overwhelming you, do not let it overwhelm you. All of you guys can count by fractions, as much as you hate that F word. Okay? So here we go. This is 1/6. 1/6 pi. All right? So from here to here is 1/6 pi. If I add on another 1/6, what are you going to end up with? Those reduce. 6 reduces 1/3. Reduce as you go, okay? But remember, this is 2/6, because when I add another 2/6, what is this going to be? I mean, sorry, I said that wrong. When I add another 1/6, what is that going to be?
1/2.
Good, because what did you get it from?
3/6.
3/6, very good. So 3/6, notice he recognizes 3/6 is just 1/2, so he reduces it to pi over 2. But keep counting by 6. Now some students say, can I just do all of them, count by 1/6, and then go back and reduce? Absolutely. So 1/6, 2/6, 3/6, 4/6, 5/6, keep going, 6/6. So keep going all the way around, and then go back and reduce if you need to. Some people reduce as they go, some people just do it after. You choose the path that you want to do. So go ahead, keep counting by 6. So notice all you're doing is you're adding 1 to the numerator every single time. The denominator stays 6 every single time. 7 over 6. You're still skipping the 45-degree angles like you did with 30. Okay. 8 pi over 6. And you will stop when you go full circle. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Go back and reduce. Sometimes you reduce. So all degrees counting, missing so any questions about here so far? All right. We get these, well, we do the same thing we did over there. Let's work with 45. Let's convert 45 degrees into radians. So I'm going to come over here to the upper left corner here, and I want you guys to find what the radians are for 45 degrees. So I'll let you guys work this out for a second. So multiply by your conversion ratio. All right, what did you guys get? What's the radian measure? 1/4 pi, pi over 4, however it is that you want to say it, okay? So I'm going to come over here and put pi over 4, okay? So instead of now counting by 1/6, instead of counting these little measures here of 1/6, I'm going to count these measures of 1/4, okay? So I'm going to kind of path it here on the outside to visually help you. So from here to here was 1/4. I'm using this whole arc right here as a reference. So 1/4 plus another 1/4 will give me what? What's 1/4 plus 1/4? Good. He's getting 1/2 from 2/4, right? But it's already filled in, so I don't have to worry about it. What's adding another 1/4 make? I heard 3/4. That's correct. So let's write 3/4 here. 3 pi over 4. It took 3 hops in fourths to get here. After 3/4, we're going to end up at
1.
Good, which is the 4/4 he's talking about. We already have it. 4/4 becomes 5/4. Very good. So keep going. All right, you should have written 7 pi over 4 for this one.
I'm just confused on this. So when you say here,
Sure.
like for you to be done during class stuff, I can like actually ask questions.
Yeah,
So
absolutely.
like
So you just did the 1/4, right?
yeah, 1/4.
So we did, so put pi over 4 there. Good. So we hopped 1/4, 2/4.
So 2 pi over 4.
But isn't 2 pi over 4 going to reduce to pi over 2? Right?
So pi over 2.
So you ready? Well, you actually have it there already, because look, if you divide this by 3, that's a 1, and that's a 2, right?
Yeah.
So you don't have to do it again, because it's done there for you. After 2 pi over 4 becomes?
3 or 3/4.
Good. So write that. Okay. So everybody good with the degrees and the radians? No problems? All right. So that earns you a 67% on the quiz. Okay. So what you will notice is that at this point, what you guys have found are all these degrees, and you found all these radians right here. Okay. Now we're going to work on finding these numbers. All right. So we are going to not have to do every single point. So when I start doing this, don't think, oh my gosh, this class is never going to end because we're going to do for every single point. No. This is a very much unit school built on symmetry, so you'll see that that's not the case. Okay. All right. So what you're going to do is take one of your colored pencils. And you are going to highlight this 30-degree segment right here. Okay, so you can share with one another if you need to. So from the center all the way to this dot right over here, accentuate this 30-degree angled dot, because we're looking for the coordinates of that unit circle. From that dot, I want you to draw a line vertical dropping down to the standard axis where you start your angle measures. Yeah, they are. You see in that box over there? You can get one in there. So what you guys are going to see is we're going to show you how this right 3, 2, trying to use notice, and this here is 60. So that's a 30-degree triangle. Everybody with me so far? Yes? Silence means we're good. So what we're going to do is do what we've been doing in section 3.2. Go up here in this upper right hand corner. And by the way, everything we're doing right now, you will not be doing on the quiz, okay? This part here that I'm showing you is not going to be on the quiz. I could have easily just showed you the pattern of how we're number teaching. I want you to understand where numbers come from so that you can at least respect unit circle. Maybe you'll never fall in love with the unit circle, but at least you'll have some, okay? So here we go ahead. On the 30 degree. Yeah, you got it right. I'm going to show you how these numbers are coming about. So here we go. So let's go up here to the top, and we're going to say that we're working with 30, 60, 90. Make that little chart that we've been doing with section 3.2. And then I'm going to write down the ratios that you guys already discovered with your Desmos activity and whatnot. Okay. Now, I have to give you a length of a side to be able to determine the length of the other two sides. Now here's what you notice right now. Right now on this drawing, on mine, there's no length of any sides given to you. Okay? But here's what I do want you to recognize is that it is given to you. The title of the unit circle is called the unit circle, and unit plays a role as to why they use the word unit. If you think of the word in Latin, breakdown, or Spanish, uno means what? Means one. So what they're telling you is that for the unit circle, the radius of the unit circle will always be a 1. Okay? Well, as far as the unit circle is concerned. Okay? So every single one of these right here, every radii that you see on this unit circle is a length of 1. So if you look at your triangle, you'll notice that the length of this side is a 1 because this is the unit circle. What is the length of this side? Which side is it when it comes to this chart, that 1? Very good. Hypotenuse under the 90 I'm hearing. So let's put the 1 right here. Okay. And I'm highlighting this chart in orange so that you know that when you look back at your notes that this has to do with my orange triangle. So the 1 is across from the 90. I can use this information to help me find my x. So I'm going to set 2x equal to 1, x by dividing by 2 on both sides, and I'm going to get x equal to 1/2. That's what you've been doing in section 3.2. I'm going to take that x value that I found and populate both these missings. Here across from the 30, I needed an x. Well, I found my x. It's 1/2. Here across from the 60, I needed the x to multiply by square root of 3. Well, if I do 1/2 times square root of 3, I get square root of 3 over 2. So I found the length of both my missing sides for the orange triangle that I drew. So I'm going to take that information
2x.
across from 30. I need to label my side as 1/2. So across my 30 angle, I'm going to label this as 1/2. Across from 60, I'm going to label my side square root of 3 over 2. Across from 60, square root of 3 over 2. Now, you still probably are saying, okay, I still do not understand why you're showing me all of that. So here, hopefully you'll start seeing why. Okay? So here's where you are right now. You use the chart to figure out the lengths of all the sides in this embedded triangle. Your goal is to find the coordinates of this point. You're standing right here at the origin, okay? And I need you to get to where the pencil is. So that means I need x and y distance. So if I'm standing here, I had to go to the right a certain distance. The right distance is square root of 3 over 2. That's my x coordinate. Then I had to move y distance. The y distance is up or down. I had to go up y distance. That is 1/2. These coordinates are the x and y distance, in other words, the distances of the legs to get to this point. Okay? And you guys are going to see how this unit circle helps you solve problems in the future just by knowing these coordinates. Okay? So far, are you okay? Now again, do not worry. I'm not asking you guys to do any of this descriptive discovery problem on the quiz. Okay? I just wanted you to understand where these numbers came from. Okay? If this is the 30, 60, 90, I want you to notice that if you highlighted the 60-degree triangle right here, so highlight the 61 in a different color. This is the same triangle as my orange one, okay, except it's just inverted. Okay, it's the same triangle, except that the central angle this time is a 60 instead of a 30. Okay, it's still the same triangle as the orange. So we don't have to do all that extra work that we just did to find this point, because we already know the length of the sides from the orange one. I want you to notice this. Isn't that side length right here the same as this one right here? Is it not? Right? And this one right here, this orange one, the X for the orange, is the same as the Y for the orange. I mean the green. Okay? So the dot for green is only going to be whatever the other one was flipped.
1/2 or yeah, 1/2.
So all you're doing is flipping. Because they are the same triangle. Okay. The unit circle is made up of many triangles of 30, 60, 90, 45, 45, 90. All right, we have one more to go. Let's do this one in another color. And if you're about to shut down, hang in there. We're almost done, okay? Hang in there. Okay, so here's our last triangle that we're going to build. All right, so this obviously is the 45, 45, 90 triangle, okay, the only other one that we have. Notice still that the hypotenuse is still a length of 1. So I'm going to put the 1 here just to remind you that that still hasn't changed, okay. We need now to figure out what are the x and y coordinates of this angle. So we need to figure out how long this x-axis is going to be, the x distance, I mean, and how long this y distance is going to be by creating our chart again, okay? So we're going to do that chart. We're going to go down to the bottom right since we have more space to do it down here, okay? So find some space somewhere, 45, 45, 90. And let's figure out what the length of those other sides are so we know where those coordinates come from. Okay. Again, the ratios x squared root of 2 is what you have discovered in the past. Hopefully you guys have that pretty memorized by now. And you guys know that across the 90-degree angle, the side hypotenuse is a length of 1. Okay. So I'm just shading mine so I know that that's the work for my blue triangle. Okay. So the great thing about this problem is we know that 45, 45, 90-degree angles, both these sides are always the same. So once we find the x, there's no work to get done. So we're going to set those equal to each other like we've done in the past and solve for x. X squared root of 2 equals 1. You guys know that it's always divide both sides. That's been pretty routine. And we get 1 over square root of 2. Now, what do we do? Because we don't want radicals. Is that an acceptable answer for x?
Multiply top and the bottom by square root of 2.
Very good. Multiply top and bottom by the square root of 2 to get rid of those radicals. 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is a 2. So you found the length of both your x's. Okay. Okay. Which makes sense because we knew both those sides have to be equal in length. Okay. So now we can go back to our blue triangle that's embedded in the unit circle above. And we can label those two sides with the distances that we found. Okay. So we know this length right here is square root of 2 over 2. And we know this length right here is square root of 2 over 2. So from the origin, I had to go to the right square root of 2, and then I had to go up square root of 2 over 2. They are equivalent distances. So the right square root of 2 over 2, the left, up square root of 2 over 2. Okay. So that's how those numbers have come about. Okay. All right, so how do we use that information to get all the others? We use symmetry, okay? So here's what I want to do, all the rest super. To order, except in it. You don't have to of how it was. Just have this, you know, that first quadrant with positive. So, but we know about the negative. We know positive. This green dot. Move it over. Write down this coordinate. This one's going to stay. Take move. Write the same over here. But you want negative 3 over 2 and a half. You got those 3 dots. So the writing is what's tedious. Sure. Zoom in here. Okay, so this green dot becomes this right here. So notice how it just changes the negative for the x's. Okay, that's all that keeps changing. All right. Now what you're going to do, go ahead. Here, I'll show you less noisy so you'll see it better. Sorry, there's like a major delay on the thing. So notice, so you notice how the numbers are still the same. They're still the same, except the x values are changing to negative. Okay, so literally you guys are just taking the points on the left and matching it with the points on the right. That's all you're doing. Okay, you're just matching the points. Is everybody seeing that? Then what you're going to do is you are going to take the points that you just found right here in this quadrant, the second quadrant, and you are going to drop them down to the bottom half. Okay? So you're going to take this dot coordinates and go down to this coordinates down here at the bottom. Okay. So let me go back to the original one here. Okay. So what do we know about the third quadrant though?
Both negative.
They're both negative. Very good. So here, this one right here, if you jump over the x-axis, we know they're both negative. So just think about it as you folding your paper over. Okay. Students like to use it diagonally too. If you want to use it diagonal, you can do it diagonally. Notice this diagonal, if you run across the unit circle to this one on this side, they are also identical. Make sure they're always identical on the diagonals. Okay. They always have to be identical on the diagonals. Okay. So this one and this one should be the same. This one and this one should be the same. So always check that. Okay. All right. So that's how you do those. And then of course on this side, the x's are going to be positive, the y values are going to be negative. So you can use the diagonals, or you can do the folding over of the x-axis. Okay. So whenever I give you like 5 minutes to fill this out and everything, it's this step that takes students the longest. Not that it's hard, it's just the writing. Okay. So once you have those first 3 dots in the first quadrant, everything else populates super fast. Okay. All right, we're almost there. The finish line is in sight. Okay. You have 4 dots left. I'm going to zoom out here for a second to show those 4 dots. Wow, my technology is really slow today. Okay. Okay, so there are 4 dots here that are left at the quadrangles. Okay. Those dots are easy for students to find. So here's how you do those. Okay. So these here on the, okay, if your reference point is for origin, this to get to this point on the y-axis, there's a reason why I keep saying y-axis, you had to go up 1 and you had to go down 1 from the 0. So when you guys are giving me the coordinates of this one, you went up 1 on the y-axis, so that's why I'm putting it on the y coordinate. I went down 1 on the y-axis, so that's it on the y-coordinate. Okay. I did not move left and right, so I put 0. So 0, comma 1 is the north one, 0, negative 1 is the south one. Notice these dots here are sitting on the x-axis.
So it's 1, 0, negative 0.
Very good. 1, comma 0, because you went to the right 1, negative 1, comes to the left. Notice this is on the x-axis, so you put your 1s and negative 1s on the x-coordinate. This was on the y-axis, so you put your 1s on the y-coordinate. The reason I make sure to point that out big time is that sometimes on the rush of you doing the unit circle quiz in the future, not anytime soon, students get those mixed up. So when you're doing those 4 points, make sure you ask yourself, okay, I'm on the y-axis, so I better put my numbers on the y. I'm on the x-axis, I better put my 1s on the x's. Okay? Any questions?
Nope. Second.
That's it. So, show you guys what you guys are going to do with all